Welcome to YouTube channel Scientific underscore Math. We are solving a system of linear equation by LU decomposition with Gauss elimination method. In earlier lecture, we discussed what is LU decomposition, application of LU decomposition, and the procedure how we apply the LU decomposition to decompose the coefficient matrix into lower triangular matrix and the upper triangular matrix. In this lecture, we apply the Gauss elimination method to decompose the coefficient matrix into lower triangular matrix and the upper triangular matrix. LU decomposition with Gauss elimination procedure. DLU decomposition is a method for solving system of linear equation. We write the system of linear equation in this form, and when the Gauss elimination method is applied to the matrix A, this is the coefficient matrix. The elements of the matrix is lower triangular matrix and the upper triangular matrix are actually calculated. The upper triangular matrix U is the matrix of coefficient A that is obtained at the end of the procedure. It's mean when we apply the Gauss elimination method on the coefficient matrix A and we eliminate all the elements that are below the diagonal, uh, we obtained the upper triangular matrix at the end of this procedure. And the elements of lower triangular matrix on the diagonal all are ones, and the elements below the diagonal are the multiplies Mij that multiply with the pivot equation. I will show you this when we explain the example related to the Gauss elimination procedure. Okay, so in generally, for example, we have the coefficient matrix in this one, and we decompose the coefficient matrix into the lower triangular matrix and the upper triangular matrix, where the elements a2 m21 is equal to a21 and divided by the a11. This is the multiplier that we multiply with our pivot equation, and similarly so on. I will explain later with the help of example. Okay, so first we discuss the procedure, how we apply the Gauss elimination procedure on the coefficient matrix, and then we get the lower triangular matrix and upper triangular matrix. So the method procedure, the method for solving the system of linear equations, we write in matrix form. And what is the first step? The matrix of coefficient, this one is first decomposed into a product of two matrices, that is lower triangular matrix and the upper triangular matrix. So here the A is decomposed into the lower triangular matrix and the upper triangular matrix. Both these matrices are square matrices, like the A is the square matrix. Okay, so we replace A with upper and lower and upper triangular matrix. This equation become like that, and now we multiply. In next step, we multiply the lower triangle upper triangular matrix with x, and we took this equal to any arbitrary column, arbitrary column vector and column matrix. This one we name this as first equation, and in three step we multiply in this column vector column matrix with the lower triangular matrix, and is equal, we take is equal to b, and we give name equation 2. Okay, so the solution of x is obtained in two steps. First, we solve the equation 2. We solve this equation with forward substitution, and then for y, then the solution of y, the solution we have obtained in this equation, we substitute in equation 1 here. Here we substitute this here, and then we solve for x, and here we apply the backward substitution to solve the equation 1. Now we solve example related to the LU decomposition with Gauss elimination procedure. Example: solve the system of linear equation by LU decomposition with Gauss elimination method. With Gauss elimination method or procedure. So we have a given system of linear equation. First we write the system of linear equation in matrix form, Ax is equal to b. Okay, so we have the matrix from this one, and this is our coefficient matrix. We decompose this matrix into lower and upper triangular matrix by applying the Gauss elimination method. So the first step is the matrix of coefficient is first decomposed into a product of lower triangular matrix and the upper triangular matrix. Okay, so we write the coefficient matrix A is equal to, this one is the lower triangular matrix and this one is the upper triangular matrix. Now we find the upper triangular matrix by applying the Gauss elimination method and the lower triangular matrix. So applying the Gauss elimination method to get the upper triangular matrix and the lower triangular matrix. In earlier lecture we have and discuss the Gauss elimination method. Okay, how we apply the Gauss elimination method and how we eliminate the terms that are below the pivot equation, that are below the pivot coefficient. Okay, so here we have this one is the pivot row and this is the pivot coefficient. We eliminate all the terms that are below the pivot coefficient. So how we eliminate this term? We multiply the pivot row r1 with 4 divided by 2 and subtract from the row 2. This will give us a new row 2. Okay, so and similarly we get the and the element of low triangular matrix L21, that is equal to A21 divided by A11. This is A21 and this is A11, which is equal to 4 divided by 2. This one, this will give us is equal to 2, means L21 will be 2. So and here we can see that this is eliminate now, and here we get the term L21. So next we eliminate this term and we will get also the element of low triangular matrix L31. So we multiply the pivot equation with 2 divided by 2 and pivot row and subtract from R3. This will give us R3, and here we have L31 is equal to A33 A31 sorry divided by A11. This is equal to 2 divided by 2 and this will give us L31 is equal to 1. So now we have this one is also eliminated now, and here we get the L31 is equal to 1, and now we eliminate this term, and in this scenario we have the pivot equation is a pivot row. This is the pivot row, and now we have the pivot element, this one. So we multiply the pivot row with 3 divided by 1. This is pivot row and subtract from R3. This will give us new R3, and here we get L32. This is equal to A32 divided by A22 pivot pivot coefficient. This is 3 divided by 1, and now we have L321 is equal 32 is equal to 3. So here we have this one and this one. Okay, now we can see that this is now eliminated, and here we get the value of L32. So this is our the upper triangular matrix, and here we can see that all the terms that are below the diagonal all are 0. So this is our upper triangular matrix and this is the lower triangular matrix. So this is the upper triangular matrix and lower triangular matrix. Now we write A is equal to the lower triangular matrix and the upper triangular matrix. Okay, so this one is equal to this one, and we solve this in first equation, first step, and step 2 is equal to lower upper triangular matrix into the vector matrix X is equal to any arbitrary vector matrix Y. This one is equation 1, and equation step 3 we have this one, lower triangular matrix into the upper triangular into the column matrix y is equal to b. First we solve this equation and find the values of y, which then we substitute in equation 1 to find the values of x. So here we solving equation 2 to get the values of unknowns y1, y2. Here we have y is equal to y1, y2 and y3. This is the vector matrix. Okay, column matrix, sorry. So uh, this one is equal to lower triangular matrix into the column matrix y, which is equal to b matrix. So we multiply this one with this one, we get y1 is equal to 11. Then we multiply with this and we get y is equal to y2 is equal to 6. We substitute the value of y1 over here and we will get the value of y2, and similarly we get the value of y3. Now we have the values of vector matrix y is equal to 11, 6 and 2. Now we substitute this in equation 1 to find the values of x. So now solving the equation 1 to get the values of unknowns x1, x2 and x3. X is equal to column matrix x is equal to x1, x2 and x3 of dimension 3 cross 1. So here we have this one upper triangular matrix, and this is the column matrix x, and this is y. So now we apply the backward substitution over here. Here we apply forward substitution. Forward. So okay, now we multiply this one with this, we get x value of x. Then we multiply this one with this, we get the value of x2. Then we multiply with this row with this column, we get the value of x3, x1, sorry. So this one x3 is equal to 1, x2 is equal to 2 and x1 is equal to 3. So this is the solution of system of linear equation. And thank you so much for watching my video. Please subscribe my channel for more videos. In this in next lecture we will decompose the triangle coefficient matrix into lower and upper triangular matrix by using the Gauss elimination method with pivoting.